Hello student, welcome and very good morning to you. Today I will be discussing the solution of question number 17, 18, 19 of ERODOV. This discussion will be extremely helpful for the preparation of JEE Main and JEE Advanced. I have already uploaded the easy solution of question number 1 to question number 16 of ERODOV. If you watch this video, you have concrete idea about relative motion and kinematics. Please share and like the video and please write a comment on this video because this comment will be extremely helpful to make the next video for you. Look at this question number 17. From a point A located on the highway, one has to get by car as soon as possible to the point B located in the field at a distance L from the highway. It is known that the car moves in the field n times slower than the highway. At what distance from the D one must turn off the highway? Look at this. Suppose this is the highway. This point is the point A and this is the point D. Now B is a point at a distance L from the highway. This distance L. Now we have to calculate the distance from D. Suppose this distance X, where the car turn off. That is the path of the car from A to C and then C to B to reach the B at the least time. Okay. Now here distance AC is equal to this is the AD minus X and distance CB equal to look at this is the root under of this is the L square plus X square. Now what is the time to reach from A to C? This is the distance by speed. So T equal to look at this is the AC by this is the N into V because velocity on the field is N times slower than the velocity on the highway. So velocity on the highway NV and velocity on the field is V. Now look at this here time taken to reach from C to B. This is the CB by this is the V. This equal to this is the AD minus X by N into V plus CB. This is the root under of L square plus X square divided by this is the V. So time becomes minimum if dt by dx equal to 0. So look at this dt by dx. This equals to 0 minus 1 by n into v plus look at this the differentiation of root over L square plus X square. This is the 1 by 2 into root under this is the L square plus X square into differentiation of L square is the 0 plus differential X square this is the 2x into 1 by v. Look at this as dt by dx equals to 0. So look at this here 0 equal to minus 1 by nv equal plus this is the look at this these 2 and these 2 cancel out. So look at this x divided by root under of L square plus X square into 1 by v. So look at this here 1 by nv this equals to x by root under of this is the L square plus X square into 1 by v. Now look at this here v and v are cancel out. So look at this here n square X square this equals to this is the L square plus X square. So from here this is the X square into n square minus 1 this equals to L square. Therefore x equals to L by root under n square minus 1 is the distance of D where the car turns to reach the point B in the least time. Okay. Now question number 18. A point travels along the x-axis with velocity whose projection Vx is represented by the function of time by plotted in figure 1.3. Initially, the velocity increases from 0 to 1 in 1 second. and then constant velocity up to 3 seconds, then decrease to 0 at the 4 second and gets the negative value. Look at this, this is the 2 at the t equal to, this is the 6 second, and finally at 7 second reaches at the OX line. Okay, so look at this. First of all, look at this. Assuming the coordinate of the point x0 and moment t equal to 0, draw the approximate time dependence of plot of the axis, time dependence of acceleration. So look at this, from t equal to 0 to t equal to 1. Acceleration equal to, look at this, 1 by 1. So this is the 1. From t equal to 1 to t equal to, this is the t equal to 3, this is the a equal to 0. Then t equal to, look at this, t equal to 3 to t equal to, this is the 6, this is the retardation. And retardation and value of retardation, this is the, look at this is the 2 by 2. So this is retardation is equal to a equal to, this is the minus 1. And finally, look at this, t equal to, this is the 5, t equal to 6 to 7, this is the acceleration, and this acceleration is equal to 2. So look at this is the acceleration time graph, this is the time t, and this is the acceleration a. So look at this is the constant acceleration, this is the zero acceleration up to 1 to 3 second. Okay, then look at this is the retardation. Now retardation, this is the 3 to, this is the 6 second. And then acceleration, look at this, then look at this is the 6 second, and then acceleration 2 meter per second from 6 to 7 second. So look at this, acceleration, retardation, and again acceleration. Okay, now we have to calculate displacement. Look at this, from 1 to 2 second displacement is the half. From 1 to 3 second the displacement is, look at this is the half into, this is the 2 into 1, plus look at this is the 3 to 4 second displacement is half into, this is the base into altitude. Now from 4 to, look at this, from 4 to 7 second, this is the half into, base is the 3 and altitude is the 2. Okay, so look at this is the minus 3, and look at this also plus, look at this is the minus 3 and this is the plus 3. So displacement is 0 and distance coverage, look at this, 3 3 plus 3, so distance is 6. Therefore, look at this, the xt graph becomes, look at this way, increases then decreases to 0. Okay, okay, this is the displacement time graph. Now distance time graph, look at this, the distance time graph, look at this is the distance, this is the distance, and this is the time. Look at this, up to this, then it bends in upward direction. Look at this is the in upward direction. Okay, because distance is never be negative. And look at this portion is mirror image of the this portion. If mirror is placed here, this part. Okay. This question number 19. A point traverses half a circle of radius r equals to 160 centimeter during the time interval tau equal to 10 seconds. Calculate the following quantity average over that time. Mean velocity. Look at this mean velocity, that means speed. So look at this in semicircular path. Look at this is the semicircular path. So look at this, the distance covered. Okay, so mean velocity, distance covered, this equal to, look at this mean velocity, that is the distance covered, this is the pi r by t. Look at this here, pi r, pi is the, r is the, this is the 1.6 meter and t is the 10 second. So look at this is the 0.16 pi meter per second is the mean velocity. Okay, now modulus of the mean velocity vector. Now velocity vector means velocity. So velocity vector, v vector this equal to displacement by time. The mean value of average velocity, this is the displacement time by this is the displacement by time. So this is the 2r by t. Look at this. This is the 2 into r is the 1.6 by 10. So look at this. This is the 0.32 meter per second is the magnitude of average velocity. Okay. Now modulus of mean velocity vector. Now modulus of the mean vector of the total acceleration. Now look at this here velocity v directed. This is the 3. Look at this here velocity. This is the 0.165 directed along this direction. Here velocity here directed 0.165 along this direction. So acceleration is equal to, look at this. This is the final velocity. This is the minus 0.165 minus this is the 0.165 into minus, that is the plus, divide by time. Time is the 10 second. So look at this. This is the negative sign of 0.32 by 10 into pi. Therefore, this is the negative sign of 0.032 pi meter per second square is the acceleration. Okay, understood? Now question number 20. The radius vector of a particle varies are equal to this, where a is constant and alpha is positive factor. Find velocity v and acceleration w of the particle as a function of time. Look at this here, position r equal to, this is the at minus this is the a alpha t square. Therefore, velocity v equal to a into 1 minus this is the a alpha into 2t. Now acceleration a equal to this. Now acceleration omega equal to this is the dv by dt. Therefore, look at this. This is the 0 minus this is the 2a alpha. Okay, no problem. Now the time interval delta t taken by the particle to return the initial point. Look at this. When the particle returns to the initial point, here r equals to 0. So look at this here. This is the at minus 1 minus alpha t. This equal to 0. Therefore, 1 minus alpha t. This equal to 0. Therefore, t equal to 1 by alpha is the time taken by the particle to reach the initial position. Okay. Find distance. Find the distance covered during that time. Look at this. First of all, we have to calculate the time at which velocity becomes 0. If we put v equal to 0, then look at this. This equal to, this is the a minus 2 a alpha t. Okay. So look at this here. 2a alpha t equal to a. Therefore, look at this, t equals to 1 by 2 alpha. And maximum velocity v max, this equal to, look at this, from this equation the velocity becomes maximum when, look at this negative term will be 0. So look at this, velocity becomes maximum at the initial. So velocity becomes maximum when t equal to 0. So maximum velocity a. Now distance covered. Now distance covered from initial position to 0 velocity position. So this is the v square by 2 into acceleration. What is the acceleration? Look at this. V square is the a square and acceleration is the, look at this, acceleration is equal to 2a alpha. So look at this. This is the 2 into, this is the 2a alpha. This and this cancel out. So look at this. This is the a by 4 alpha. Therefore, total distance, this is the s dash equals to, this is the this distance and this distance. So twice of this found part. Therefore, look at this. This is the a by 4 alpha into 2. Therefore, a by 2 alpha is the distance travel. Many thanks for watching this video. This video will be extremely helpful for your preparation in NEET, main and advanced. Okay, thank you.